Today we're starting lesson 5-2, which is multiplying powers or exponents with the same base. There's one primary rule, and that is that when multiplying powers with the same base, and that's important, that you're adding your exponents, okay? So for example, we have a base of A and a base of A. Well, since those are the same bases, all we have to do is add the two exponents n plus n, okay? Here we have, let me finish. Here we have a base of 3 and a base of 3. So when we take our base of 3, we just add the two exponents, 2 plus 3, and we get 3 to the 5th power, and 3 to the 5th power is 243. So this first page deals with these types of problems. And then we'll have some that don't have, they'll have coefficients added to it. And we need to make sure we don't get our bases and our coefficients mixed up. Okay, so here we have 12 to the power of 4 plus the power of 3, which gives us 12 to the 7th. Okay, we're not going to figure out what 12 to the 7th is because it's really big. Okay. Okay, going down to example 2, we have the same base of -5 for each one of these. So I'm going to write -5, and then we have an exponent of -2 plus an exponent of -3 plus an exponent of 7. So you're just combining like terms. And remember, when we're adding and subtracting, we just we add and subtract from left to right. So the first thing that I'm going to do is take my -2 plus a -3, and I get 5 to the power of -5 plus 7. And then I take -5 plus 7, and I get 5 to the power of 2. And 5 to the power of 2 is 25.
Why is it no longer a negative? Why is the coefficient? Sorry, I forgot to.
-5 plus 7 is a positive 2. Oh, the base, it is negative. I'm sorry, I forgot to bring in my negative.
But it's still equal 25 because negative
Yeah.
is negative.
There you go.
No, wouldn't it equal?
-5 times -5 is a positive 25.
Yeah, but isn't it times?
All right, example 3. Now remember, you have to look at the bases, and you can only combine exponents if their bases are the same. So in this case, we have two bases of A. So we would have A to the power of 5 plus 3 times B to the power of 3. And we can't combine that with anything because there's not another B. So we simplify this by adding our exponents at the base of A. So we get A to the 8th times B to the 3rd. And you do not need a multiplication symbol in between your letters when they're side by side with nothing in between. That means you are multiplying them. Okay. Okay. Example 4. Now this is when you have coefficients that are attached. Remember, if your coefficients don't have exponents, then you're just going to multiply them together. So in this case, I'm going to take 4 times 9, okay? And then I can combine my bases together. So I have z to the power of 5 plus a -5, okay? So any coefficients, you just multiply them all together. And 4 times 9 is 36. And then you have z to the power of 0. What is z to the power of 0?
1.
1. So really you just have 36 times 1, which is 36. And that's your final answer. Okay. Okay, so for example 5, I am going to multiply all of my coefficients together. So I have 2 times 9 times 3. Then I multiply.
Nine is a B. Yeah, 9 is B.
Okay, it doesn't matter. It doesn't matter where your coefficient is. All your coefficients will be added together. It's your variables that matter. You have to have the same variable in order to add your powers. So in this case, I would take a to the power of 1 plus 2, because this has a 1 there, even though we don't see it, times b to the power of 4. Okay, so it doesn't matter the order you multiply. I know that 2 times 3 is 6, and then I can easily multiply that by 9 to get 54. And then now we have a to the 3rd power and b to the 4th power.
And that's it?
Yes.
Wait, what? You can-
This lesson's a lot easier than last time.
Okay. On example 6, I have a negative b. Remember, that's a negative 1b. So when I multiply my coefficients, I have a negative 1 times 5 times 13 times 6. So all of my coefficients will be multiplied together.
I'm confused.
You're taking all of your coefficients and you're multiplying them together.
Oh, cool.
Okay, and then my variables, I have A's and B's, so I always start with the first letter of my alphabet. So I have a to the 4th plus a negative 5. And then I have b to the 3rd plus 1. It's a big old line of stuff, and you might set yours up a little differently, and that's fine. So I have a negative 5 times 18. So let's figure out what that is. Okay, so I get a negative 90, right?
I thought.
Oh, I'm sorry, that's
You
wrong.
times it by 6.
That's wrong. It's negative 5. I was thinking 6 times 3. 13 times 6. Okay, yeah, negative 30 times 13. That's what I'm going to do. Negative 390. A lot different. Okay. Negative 390. And then my A, 4 plus a negative 5 is a negative 1. And then b to the 4th power. Yeah, now since we have a negative exponent, we're going to take this one and move it to the bottom. So we have negative 390 b to the 4th over a.
Okay, that kind of confused.
Okay. Now with number 7, I will have you do this on your own, but I am going to just show you something really quick. This is another way right here of writing a problem like they did up here. So I could have had 8 a to the 4th b to the negative 3rd times negative 4 a b to the negative 12th. They just put parentheses around it instead of having a dot in between it. But the process is still the same. Multiply your coefficients together and then combine your same bases. Okay, so go ahead and try that one. Okay, and go ahead and check your answer for for number 7. Okay, page 2, we're going to look at how to use the distributive property to simplify rational expressions. So all we're doing here is we're taking 5x squared times negative 3x cubed, and then 5x squared times negative 1x. Okay, so 5 times 3 is negative 15. And then x squared times x cubed,
X6.
x to the 5th. We're adding, not multiplying.
What? But you-
We're adding, not multiplying. 2 plus 3 is 5.
You never multiply. What?
No, you never multiply exponents.
No, you do, but not in this case.
Okay.
That's, remember, the very first phrase up at the top is when multiplying powers with the same base, you add the exponents. Okay, so then we take 5x squared and we multiply it by a negative 1x and we get negative 5x
3 cubed.
cubed. There you go. So that would be your answer here.
Wait, don't we add the X's? So you can add the X's.
No.
Oh,
Okay.
okay.
Remember, when multiplying powers with the same base, this isn't multiplication, this is subtraction right here. So we cannot combine these because it's subtraction.
So we can subtract them.
No, we can't, because in order to add or subtract, we're not even worried about adding and subtracting right now. But in order to add or subtract these, they have to be the same base raised to the same power. And we're not there yet. Right now, we're just multiplying powers with the same base. So now we're going to take negative 3x cubed and we're going to multiply it by negative 4x to the power of 1/3. And then we're going to multiply it by 7. So go ahead and see if you can do that. So when I distributed negative 3x cubed to negative 4x to the power of 1/3, I get 12x to the power of 3 plus 1/3. Don't try to multiply these. Okay, you're adding these. And then I distributed negative 3x cubed to positive 7, and I get negative 21x cubed. So in order to finish out this problem, you have to add 3 plus 1/3. Now, 3 plus 1/3 can be done as 3 and 1/3, and then you just turn it into an improper fraction and you get 10/3. Okay, that's the easy way to do it. The hard way is to take 3/1 plus 1/3, find common denominators. You end up with 9/3 plus 1/3, which gives you 10/3. Okay, so the final answer here would be 12x to the power of 10/3 minus 21x cubed. Wait, hold on. So with example 9 done, we can now move into scientific notation and exponents and what this will look like. So I want to read through the steps first, because once I read through them, I think that most of you will be able to move along. So it says, multiply your first two numbers in each parentheses together, which means we would multiply our 8 and our 2 together.
Oh, it's just like y1 minus y2.
Step 2, multiply your two base numbers with exponents together. So this would be 10 to the 5th times 10 to the negative 4th.
14.
No. Okay, let's finish.
So how do you get 4?
So then 8 times 2 is 16.
Wait, but I thought it was going to be 4.
Yeah, it is. Sorry.
Okay.
And then times 10 to the 5th plus a negative 14. Okay, which gives you 16 times 10 to the negative 9th power.
Now you gotta flip it over there.
Well, that is, hold on just a second. Okay, so this, we're kind of done. We're almost done, but we have one step left. If you've already been taught scientific notation, you should have been taught that the correct way to write it is to have the decimal right after the first number. Okay. So the correct way to write the scientific notation would be to write 1.6 times 10 to something. Okay.
Oh, yeah.
That's just the correct format for scientific notation. So when you look at a whole number, we don't see a decimal there, right?
No.
So when there is no decimal, we put it at the very end of the number. In this case, it's right here. However, We need it to move one place to the left so that we can write it properly as 1.6.
Because it's times 10.
Right.
So if it was times 100, it would be 0.16.
Wait, how is it not 10?
Hold on. So if you move the decimal to the left, you're going to add to the exponent. We moved it one place to the left, so we're going to add 1 to the exponent. If we would have moved it 2 places to the left, we would have added 2 to the exponent. Okay. So then it becomes 10 to the power of -8.
We have to do that.
Yes, this is how you would do it for scientific notation.
Wait, I have a question.
So for the second one, we're going to take 0.7 times 0.2. And we're going to times it by 10 to the -5th plus the -4th. Okay. So we should get 0.14 times 10 to the power of -9.
Oh,
Now-
also have another question.
This time, hold on, we need to move it one place to the right. So now we're going to subtract from the exponent. And you end up with 1.4 times 10 to the power of -10. And I want you to try number 12 on your own. Okay, so after I do my combining, I get 0.9 times 10 to the -3rd. I have to move my decimal over one place because it has to be after the first number. So when I move it to the right one, I subtract from the exponent and I get 9.0. Did we lose connection?
No.
Maybe she lost connection. Okay.
She's like,
Okay. Let's go ahead and I'm going to see where I'm at. We are going to move on to page 3.
You're on mute.
Thank you. Sorry about that. Okay. I'm not sure how much you got on that, Catherine. Did you finish up page 2? Okay, now we're going to simplify multiple expressions with exponents that are fractions. So again, you're going to multiply all of your base numbers together, combine all like terms or like bases, multiply all like terms by adding your exponents, and then simplify if you can. So in this case, all right, we are going to take 2 times 3 times 1 times 5. We're multiplying all the coefficients together. Now we're going to combine all of our like bases. So we have a to the power of 2/3 plus 1/3 times b to the power of 1/4 plus 1/2. And now you're just going to simplify that all out. So 2 times 3 is 6 and 1 times 5 is 5. So you should get 30 for your coefficient.
thank you.
And then a to the power of 2/3 plus 1/3 is 3/3, which equals 1. And then b to the power of 1/4 plus 1/2
3/4.
is 3/4. Okay. So I'm going to simplify this even further. I don't need a to the power of 1, so it's just going to be 30a b to the power of 3/4. And that's my final answer for this one. Okay. Okay, I want you all to try number 14. And it is a little bit tricky. You're going to have to add some fractions together, but just try your best. Okay, this is what you should have gotten for 14. Go ahead and check your work. Okay, let's move on down to the bottom half of this page, how to simplify rational expressions with a missing exponent. All you're doing is you're setting the exponents up as equations and solving for the missing variable. So in this case, we know that because they have the same base, all we do is we add up their exponents, right? And that's going to give us whatever this answer is here. So we're just going to take -3 plus 6, and that's going to give us x. Well, what is -3 plus 6? 3. So 3 is what x equals. Okay.
I'm okay.
Wait, why'd you write the 7?
No,
We're just trying to figure out what the exponent is. Missing exponent. And if you look on your homework, they have it, I think, as a box.
Yeah.
So this is what your homework looks like. These boxes just represent the x's. Okay, so let's go to number 16. This time we have x plus 6 equals 4. Okay, so we're just solving an equation for x. So subtract 6 from both sides and we get x equals -2. Okay. Go ahead and try number 17. And go ahead and start on number 18. Okay, check your answers for 17 and 18. Okay, let's go on to page 4. This is very brand new. And so Momo was asking if we're going to learn how to solve these. And yes, we are. This is a very brief introduction when you have a fractional exponent that has a 1 in the numerator, because if your numerator has like anything other than 1, it makes it's a little bit different. So when your number is raised to a power that is a fraction, and that fraction has a numerator of 1, such as this right here, you will use a factor tree to determine what number is being multiplied 6 times by itself to equal 64. Okay. So the way that you would actually write this, though, would be, let me make sure. Oh, I don't have these in here. So it would be 81 in a square root, and you have a 4 right here. And what this is saying is what number is being multiplied 4 times to get 81. Okay, so I'm going to use a factor tree. And you guys,
Wait, how do you know it's 4?
because your denominator's 4. Like this one up here was 64 with an index of 6 like this. And we're going to go into a lot more detail in this, but this is a minor introduction into what we're doing. So now I'm going to use a factor tree, and 9 times 9 is 81. And then I factor down to 3 times 3, 3 times 3. Once you get all the way down to prime numbers, you're done. So there's 1, 2, 3, 4 3s. So the answer to this is 3.
What?
Yep.
But there's 4.
Yes, because
3 times 4 equals 81.
3 to the 4th power, basically, yeah, that's what you have is 3 to the 4th power, which equals 81. So what basically it's asking, what is a 4th of,
Oh. Can't
Yeah.
you just do that?
I mean, you could, it's not a 4th though, like you don't divide by 4, it's multiples or exponents. What would basically x to the 4th power equals 81. What is that number? Okay.
Oh,
So in this case right here, you're trying to figure out, then let's do it this way. Well, we have 124 with an index of 5, or you could say what number raised to the 5th power is going to give you 1024. You could write it either way. Okay. So I would use a factor tree, and this factor tree is going to be somewhat long. You don't always have to start with 2 or 3. Okay, so in this case, I would probably, I could start with 4.
Because the 24 goes to the
Mhm.
6.
What the?
Oh, I called 911.
Okay, so after I factor 1024, I end up with all of these 2s. So one way that helps me, because this is a little bit of a mess, is I count up my 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 times 2 times 2.
So you're showing
Okay,
showing
so that's one set of 5. And then 2 times 2 times 2 times 2 times 2. That's another set of 5. So it's actually 2 times 2, which is 4. Okay, because you have to circle groups of 5.
Wait, I forgot how to do the factor tree. Mine-
Hold on, let me finish this. Okay. And that's the end of our 5-2 notes.